Inductive reasoning is looking for patterns and making a prediction. So, for example, if on Monday it rains, on Tuesday it rains, on Wednesday it rains. Somebody using inductive reasoning would say on Thursday it rains. So just because a pattern has happened doesn't mean it's going to continue. But inductive reasoning is looking for a pattern to figure out what's coming next. So a conjecture is a hypothesis or a guess on what is next. A counterexample is something that shows a conjecture is false or not true. Okay? So let's use this. So we have inductive reasoning because we're going to use inductive reasoning to find the next number and make a conjecture about the rule or the equation that describes what's going on. So the pattern is I'm going down 5, down 5, down 5. So the next number would be the number take away 5. My next number would be 10, 5. So I'm making a conjecture that 10 is my next number. This right here is the rule. The rule always needs to have a variable. So it needs a variable. Needs a variable. And the next one, what's going on with this pattern? I'm noticing that there's numbers that are divisible by 3, so I know it has something with a 3 in it. So is it being multiplied by 3? So I'll try 3n. So if my rule is 3n, that means that the first term I plug in 1 for n and I get 3. The second term I plug in 2 for n but I get 6. But there's not a 6 in my pattern. So I know it's not n plus 3 because if I plug in 1 and I add 3, I get 4. So that doesn't work either. So I'm going to try n to the third power. So if I plug in 1, 1 cubed is 3. That works. Okay, next one. My pattern's 4, negative 4, 4, negative 4. So if I make a conjecture, my next number should be 4. So 4, then negative 4, then 4, then negative 4. So what you're doing is you're taking a number and you're multiplying it by negative 1 or negative n. Next one, find the next two numbers in each pattern. So how am I going from 4 to 9, 9 to 14, 14 to 19? The pattern is I'm adding 5. So I need to add 5 to 19, so it's 24, 29. Letter B, what's going on with these? The numbers are going down. How much are they going down by? Well, this one's going down by 320. This one's going down by 160. This one, the difference is 80, so it's not going down by the same number. But if I multiply 80 times 2, I get 160. Times 2, 160. So I'm actually multiplying by a half. Letter C, What's the pattern with 1, 1, 2, 3, 5, 8? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So this has to be 13. 8 plus 13 is 21. Those are my next two terms. Draw the next figure in each pattern. They all have circles, circle, circle, circle. So a circle with a triangle with a circle with a square. But look how the triangle is on the inside and then the triangle is on the outside. But this one's the squares on the inside, so now the square needs to be on the outside. That's the next pattern. Okay, this one, they're triangle, triangle, triangle. So triangle, shade on the top, shade on the left, shade in the middle. So this must be shaded on the right-hand side. Next example, is each conjecture correct or incorrect? If incorrect, give a counterexample. So a counterexample is something that proves it's not true. So all roses are red. Not all roses are red. There are pink roses. So a pink rose is a counterexample. The opposite of a number is negative. What about if you start with -5? What's the opposite of -5? It's 5. So that's our counterexample. If a number is divisible by 4, then its last two digits are divisible by 4. So numbers that are divisible by 4 are 4, 8, 12, 16, 20, 24, 28, 32, ... So let's try 232. Is that divisible by 4? You can put it in your calculator. Yes, it is. It's a whole number. The last two digits are divisible by 4, and it works. Let's try another one. 620. Is that divisible by 4? Because 20 is divisible by 4, so let's check it. Yes, it works. So this is true. If it's true, we can't find a counterexample. D. Every triangle has 3 sides of equal length. Well, this triangle has 3 sides of equal length, but do all triangles have 3 sides of equal length? No. So this is our counterexample right here. A triangle with 3 different side lengths. Is each of the following predictions reasonable? You toss a coin 4 times, and it comes up heads each time. Is the conjecture the coin will come up heads on every toss reasonable? So just because you got heads 4 times, are you going to get heads on the 5th time and every other time? No, it's not. You can still get tails. Number 2, a child grows an inch for 3 years in a row. Is it reasonable conjecture that this child will grow an inch in the year 2020? No, because after a while, kids stop growing. So you don't always grow an inch.